Ever just stop and look up at the sky and wonder what's really going on up there? I mean, what makes the sun pop up every morning? Or why do we even have seasons? Well, today we're diving into the incredible cosmic dance our planet is doing right now. These are the big, fundamental rhythms that shape everything in our lives, from when we wake up to what we wear. So let's get into it. First up, the big one, the sun rising and setting. It's probably the most reliable thing in our lives, right? We plan our whole world around it, but what's actually physically happening to make the sun appear and disappear every single day without fail?
And while we're asking the big questions, let's tackle the other mystery, the seasons. Why do we go from sweating in shorts one part of the year to bundling up in coats another? It's this massive shift that affects the entire planet, every ecosystem, and every culture.
Well, believe it or not, the answers to both of those huge questions lie in understanding two totally distinct but beautifully connected movements our planet is making. You can think of it like Earth is performing two cosmic dances at the exact same time.
And here they are. Let's meet our two dancers, rotation and revolution. On one side, you've got rotation. That's the daily 24-hour spin that gives us day and night. And on the other, you've got revolution. That's the big 365-day journey around the sun that gives us the seasons. Let's break down that first one, rotation.
All right, first up to the dance floor is rotation. This is the move that controls the most immediate, day-to-day rhythm of our lives.
So what is rotation? In the simplest terms, it's just the Earth spinning in place, kind of like a top or a basketball spinning on your finger. It's turning on an imaginary line that goes right through the North and South poles, and we call that its axis. And how long does it take for the Earth to do one complete spin? You got it, 24 hours. That single spin is the very definition of a day. It's our planet's master clock. And here's how that simple spin creates day and night. As the Earth turns, the spot where you are is either facing the sun and you're bathed in daylight, or it's facing away from the sun, out into the darkness of space. And that, my friends, is night. It's really that elegant and that simple. That's what's behind every sunrise you've ever seen. Okay, so that's the daily spin. Now let's zoom out and look at our planet's second, much bigger dance, revolution. If rotation is the daily twirl, revolution is the grand, year-long lap around the sun. And this is the real key to understanding the seasons. So, while our planet is constantly spinning, it's also on a massive road trip. It's moving along a giant oval-shaped path, an orbit around the sun. And that whole journey takes, you guessed it, about 365 days. That's 1 year. But here's the twist. The orbit itself isn't what causes the seasons.
And this is absolutely crucial because it's where a huge misconception comes from. A lot of us think, oh, summer is warmer because we're closer to the sun. Nope, not true at all. In fact, for the northern hemisphere, we're actually closest to the sun in the dead of winter in early January. The real secret ingredient for seasons is way cooler. It's all about the Earth's tilt. Okay, so picture the Earth's axis, that imaginary line it spins on. It's not straight up and down. It's tilted at about 23.5 degrees. And here's the key. As we orbit the sun all year long, that tilt stays pointed in the exact same direction in space. So for part of the year, one half of the planet, say the northern hemisphere, is tilted towards the sun. We get more direct, concentrated sunlight. Bam! That's summer. Then, 6 months later, as we continue our orbit, that same hemisphere is tilted away from the sun. The sunlight hits us at a shallow angle and spreads out, feeling much weaker, and that's winter. Now, this tilted journey creates 4 special moments, 4 key checkpoints during the year that I'm sure you've heard of: the solstices and the equinoxes. These are like the official starting bells for each new season.
And you can see them mapped out right here. In the Northern Hemisphere, we've got the spring or vernal equinox in March, then the summer solstice in June, the autumnal equinox in September, and finally the winter solstice in December. They mark the steady progression of our planet's trip around the sun.
So what's the actual difference between these two? Well, a solstice is when our tilt towards or away from the sun is at its absolute maximum. Think of the summer solstice, the longest day of the year, or the winter solstice, the shortest day. An equinox, on the other hand, is the perfect balancing point. It's when the Earth's tilt is perfectly sideways to the sun, so neither hemisphere is tilted more towards it. And on those 2 days, day and night are almost exactly equal all over the world. Pretty cool, right?
Okay, let's put it all together now. These two cosmic dances, rotation and revolution, they don't just happen in a vacuum. They are the master gears that drive the entire machine of time and climate on our planet. And this table is the perfect summary. It's the ultimate takeaway. You have rotation, the 24-hour spin, giving us our constant cycle of day and night. And then you have revolution, the 365-day journey, which, when you combine it with that crucial unwavering tilt, gives us the beautiful, predictable pattern of the seasons.
And that is the most important thing to remember. These aren't just some abstract facts for an astronomy class. The daily spin and the yearly orbit are the fundamental framework for everything. Our 24-hour clocks, our calendars, the massive climate patterns that decide where forests grow and where deserts form. It is the very rhythm that all life on Earth has evolved to dance to.
And that leaves us with one last big thought. We're living on a planet with this incredibly stable, predictable cosmic clockwork. It's been ticking away for billions of years. But now, down here on the ground, we're seeing our climate patterns start to change and shift. So the big question becomes, how will life on Earth adapt when the earthly results of these constant celestial dances begin to change?